बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम डियर स्टूडेंट्स। आज हम लेक्चर 22 का पार्ट बी कवर कर रहे हैं, जिसमें कि हम चैप्टर 7 में सीरीज़ पैरेलल सर्किट्स हमने स्टार्ट किए थे, लेकिन उसमें जो लेक्चर 22 में कुछ टॉपिक्स हमने कवर किए थे और एक आध टॉपिक उसमें हमारे पास रह गया था, जिसको मैं आज कवर करना चाह रहा हूँ। तो इसमें जो हमारे पास हमने जो टॉपिक ऑलरेडी कवर किए थे, उसमें इंट्रोडक्शन हम इसका कवर कर चुके थे, जिसमें हमने देखा था कि सीरीज़ पैरेलल सर्किट्स क्या होते हैं। तो उसमें हमने कहा था कि जो सीरीज़ पैरेलल सर्किट्स हैं, दे आर कॉम्बिनेशन ऑफ सीरीज एंड पैरेलल configurations. Then we see just certain approaches to tackle the complex circuits which cannot be solved quite easily. So for any complex circuit we have certain approaches that we can follow to handle the problem and reduce the complexity of the circuit. So for that we have seen a general approach, then we see reduce and return approach, and in this part we will cover a block diagram approach. So let me see what is the block diagram approach to solve the series parallel circuits. Block diagram approach is employed to simplify a complex combinations of elements into simple combination of blocks which are in series or parallel. So what we do is we break the circuit into smaller blocks in which the components are either connected in parallel or in series or combination of series and parallel. So in this circuit, this is one block that is called as A. This is the second block, which consists of 3 resistors, and this is block B, and this is block C. Now let me see an example to solve for unknown parameters in this circuit. This is a circuit which is a combination of series and parallel components, in which a voltage source is applied, and these are the parameters, unknown parameters, the currents IA, IB and IC, and the source current IS, which we are interested to compute for this circuit. Now what we do is we break the circuit into smaller blocks. This is block A, which consists of only one resistor. This is block B, having these 2 resistors in parallel, and in block C these 2 resistors are in series. So for each block we simplify the circuit by looking at each block and see these components, whether they are in series or in parallel. So we start working with each region one by one. So for region A, it is very simple, that it has only one resistance of value 4 ohm. For region B, we have these 2 resistors R2 and R3, which are in parallel. So we combine these 2 resistors into a single resistor of value computed by RB equal to R2 in parallel with R3, or usually denoted with this notation as R. This resistance R, which is a combination of resistor R2 and R3, and they are in parallel. So R2 in parallel with R3. So as we see that these two resistors are of equal value, so when resistors are of equal values, then their parallel equivalent can be computed using this simple relationship, that is R by N, and where N is the number of resistors of same values. So N is in this case is 2, so R by 2, which is 4 by 2, 2 ohms. So the parallel combination of these two resistors is 2 ohms. And then for block C, these two resistors R4 and R5 are in series, so they would simply be added up to have the value of equivalent resistance of block C equal to 2 ohms. And this is the notation which indicates that R4 and R5 are in series. So for this block the resistance is 4 ohms, for this block the resistance is 2 ohms, and for this block again resistance is 2 ohms. So this circuit is simplified to this circuit, having this region has resistance 4 ohm and 2 ohm and 2 ohm. And these two are equivalent resistances from the previous circuit, in which one were in parallel, and in the second block they were in series. So again further we can simplify the circuit and see that the resistor are in block B and resistor in block C, they sit in parallel. So we can combine these two resistors to form a single resistance which would be of value 1 ohms, because these two resistors are of same value, so R by 2 and R is 2 ohm, 2 by 2 is 1 ohms. So this the parallel combination of the resistor block of block B and C would turn out to be equal to 1 ohm. So these two resistors would be combined to form a total resistance of 1 ohms, which this total combination of these two resistors sits in parallel with resistance RA, so that total resistance of the series of the circuit becomes equal to RA plus RB in parallel with C, which is 1 ohm, so 4 plus 1 is 5 ohms. So this total resistance that is seen by this voltage source would be equal to 5 ohms. So if we know the total resistance, then we can compute the source current by using the Ohm's law, as Is equal to E by RT. This E is 10 volts and resistance is 5 ohms, so current would be 2 amperes. Then you can see from the circuit that this Is is also equal to Ia, because if we consider this as a node, then current entering in this node would be equal to current leaving, so the current in this path would remain same up to this point. Then at this point the current would split into two parts. Some portion of the current would flow in this path and the rest of the current would flow in this connection. So from this we have Ia is equal to Is, which is 2 amperes. Now these two quantities have been found that each is equal to 2 amperes. Then we proceed with the other unknowns, which is IB and IC. We can see that these two resistors are of same values, so whatever the current is coming from this link would be equally divided into each resistance, because the resistance values are of equal. that is each is of 2 ohms. So whatever the current is, this current is 2 amperes. So current in this resistance would be 1 ampere, and current in this resistance would be also 1 amperes. So IB would be equal to IC, and it is equal to 1 amperes. So next thing that we want to determine is the value of the current IR2 and IR3. So this current we have computed, which is 1 amperes. Then we are now asked to find out the value of current that is coming from this link, and how much current would transferred in this path, and how much current would flow in this resistance. So from again you can see that these two resistors are of equal values, so half of the current would flow in this this resistance, and half of the current would flow in this resistance. So total current is 1 ampere, so 0.5 ampere would be flowing through R2 and 0.5 would be through R3. So from here you can see that the current through each resistor in parallel would be halved, and that is divided by 2, so the current would be 0.5 ampere through each resistance of the circuit. So this current is 0.5 ampere, this current is also 0.5 ampere, this current is 1 ampere, this is 1 ampere, this one is 2 ampere, this is also 2 amperes. Next example is solve for unknown parameters for this given circuit. This is the same circuit that we have already seen. In this circuit you are asked to find out the voltages. VA, that is voltage of this block, that is the voltage across this resistance, that with this polarity, and then voltage across voltage VB, that is voltage across the parallel combination of these two resistors, and voltage VC, that is voltage across the series combination of these two resistors. So these voltages with this given polarity is required to be determined. So how can we find out these voltages? So let me see. For that, VA is equal to IA into RA. This is the voltage drop across resistor R1, in which the current is IA. So IA into the resistance RA will be the voltage drop across R1. So IA we have computed as 2 ampere into 4 ohms, so it would be 8 volts. Next is the voltage across the parallel combination of these two resistors. So for that we can again apply Ohm's law, that IB into the resistance. The resistance is the total equivalent resistance, which we have computed in the previous slide as RB, which is 2 ohms. So IB into RB will be the voltage across this resistor, which is defined as VB. So VB would be equal to IB into RB, which is IB is 1 ampere and RB is 2 ohms, so it would be 2 volts. Similarly, voltage across these two resistors is IC into RC. RC is the series combination of these two resistors, which is again 2 ohms, so 1 ampere into 2 volts. So VB is equal to VC is equal to 2 volts. We can also check the validity of KVL by applying the Kirchhoff law in the loop. So for this loop we can we can apply KVL as this is the loop in which this is the voltage rise 10 volts, then this is voltage drop VA is 8 volts, so E minus VA minus VB, so which can be written as E is equal to VA plus VB. VA is 8, VB is 2, so adding these two turned out to be 10 volts. So 10 volts is applied and 10 volts is dropped. So this means that KVL is satisfied and our calculations are correct. So this is the summary that we have introduced in the chapter 7 with the series parallel circuits, and we see general approach, then we see reduce and return approach, and at the end we see block diagram approach. Okay, that's it for today.